Currently, renewable energy sources are not good enough to cause a revolution in our energy mix, as they are highly intermittent and we cannot control how much electricity we generate using renewable sources. On one day it may be extremely windy and we overproduce. We produce more electricity than the market needs. Currently, this overproduction is wasted. It is curtailed by switching off wind turbines and disconnecting solar panels. With energy storage, with cheap energy storage, we could collect this otherwise wasted energy and use it at a later time when renewable sources are producing less than the market needs, thus reducing our reliance on fossil fuel plants, especially gas-fueled peaker plants. This is especially important in countries with a high proportion of solar power, or a high predicted future proportion of solar power, since solar and solar cells produce the most energy at the times when demand is lowest. They have a routine overproduction. Additionally, if we look at this through a year-long scope, solar power produces the most energy during the warmer months, which coincides exactly with when we use the least energy. Therefore, we don't just need short-term daily energy storage to counteract intermittency. Seasonal energy storage will be extremely useful and valuable as well. These concepts will need to be well understood to understand why the future coming videos in this series explain potentially revolutionary energy storage technologies. If we could find energy storage that is cheap, long-term and reliable, we can vastly increase the proportion of renewable energy sources in our mix and move towards our carbon neutral future. We will have a look at chemical energy storage methods such as the redox flow battery and the lithium ion battery. We will also cover mechanical energy storage methods such as the hydro pump, the potential for recreating a hydro pump using large concrete blocks, and with compressed air energy storage. Not mentioned in the coming videos are solid state batteries, as they are extremely varied depending on who's developing them, and their downsides are often hidden as they're being developed by private companies. And I will also not be discussing any thermal energy storage methods, as these also tend to be quite new in early on research phases. You may also notice that in the coming few videos, the energy storage methods I'm analysing are mainly targeted towards grid scale applications. This is because currently the new types of energy storage being developed, apart from the solid state battery, are developed with grid scale applications in mind, and they all have a very low energy density. They would not be able to compete with the lithium ion battery in any way. Thank you for listening, and I hope you enjoy the coming videos in this series.